So let's have our very first problem. So we have a structure supported by four concrete columns, square columns per floor modeled as shown. The compressive strength of the structural members is 21 megapascal. So this is a concrete, diba? So we have our 21 megapascal, which represents the compressive strength of the concrete. Dimensions of the column were 300 millimeters by 300 millimeters. H1 is equal to 1.25, H2 is equal to 1.333, H3 is equal to 4 meters. Mode shape factor for the third floor is equal to 1. Take note man nga mga butang nga. There is a sign of equality pasabot H1 is equal to 1.25 H2, that is also equal to 1.333 H3 is equal to 4. And then for the mode shape factor, take note as well of this one because yung gingon diri for the third floor, yung mode shape factor is 1.0. So other problems might give you that the mode shape is at second floor or probably in the first floor. No, masigna nga lang ang mga cases. So you need to watch for that. Watch out for that. So, sige, sa may next step. Tanaw na naton sa gipangita. First gipangita, stiffness sa usa ka column and the equivalent stiffness per floor. So mo na itong button karon no. Kuha na itong stiffness sa usa ka column and then the equivalent stiffness kada floor. Afterwards, natural frequencies. Take note this is in plural form, frequencies. This because in the MDOF system, dagan na tawag frequency. So, unsa may pattern na kung pila ka floors, that is as well the number of frequencies and the number of period. So, pangitaan mo tag period diri. And as well, that is equal to the number of the mode shapes. Again, lahi si mode shape factor, lahi po si mode shapes. Mode shape factor nag-describe sa behavior kada floor, siyang pattern. Mode shape is the overall behavior of the pattern of deformation sa building sa usa ka specific nga frequency. So in this example, we have 3 floors. Since we have 3 floors or 3-story man siya, we're expecting 3 ka natural frequency, 3 ka period, and 3 ka mode shapes. Next is we're asked to find the mode shape factors per floor and sketch the mode shape. So we have a given mass. On the right side, we have a figure with a given mass. First floor at 5,000 kilograms, second floor at 2,500 kilograms, third floor at 1,250 kilograms. So first step, ganin sa buhaton, we're going to get the stiffness matrix and the mass matrix. But before that, to get the stiffness matrix, we need to get the stiffness of the single column and the stiffness, the equivalent stiffness per floor level. So let's start with our solution. First, we're going to get the centroidal moment of inertia. The centroidal moment of inertia is BH cubed over 12, and then since this is square, that's why I just wrote there B4 over 12. Since there's only the dimension of the column is uniform throughout the floor and throughout the building, isa ra ka inertia or I itong gikuha. So 0.3 meters to the 4 divided by 12, that is 6.75 times 10 to the negative 4 meters to the 4. So nakuha tag I because to get the stiffness, we need to get the E, the I, and the H. So we have the I next is we're going to get our E. This is concrete, 21 megapascal. Then we can apply the 4,700 F prime C, or our elasticity is equal to 21,538.10577 megapascal. And we just substitute that to the equation of our stiffness of EI over H cube or H1 cube. We have the stiffness of the single column is equal to 2,725,916.512 Newton per meter. Now, take note that in these calculations, no, ngani na nga terms atong gamiton. If na C, that represents the stiffness of a single column, So let's say na ay let's say K1C, K2C, K3C. No, we're talking about the stiffness of single column. Kung walay C, like K1 lang, K2, and K3. Now, we are going to use these terms to denote the equivalent stiffness of the columns per floor level. So for our first floor, we have 4 concrete columns. We just multiply it to 4. Our calculate the stiffness of a single column. We have an equivalent stiffness sa itong first floor columns as 10,903,666.05 Newton per meter. Take note that this is the first floor. And ato ang first floor column, kinsa ang first floor column na to, dili kaning nasa ibabaw ng first floor. The first floor columns are the columns supporting the first floor. Mo na to ang kuan ang gamiton kung kinsa ang nag-support kang first floor, hunana na lang siyang mura siya SDOF ba. Tulo ka SDOF kag ipatong-patong, that is MDOF or 3 degree of freedom system. Next, we're going to get the stiffness of the second floor columns. Again, lahat man din sila height. By the way, no, I have forgotten to share you. Since we have an equality here, so ipasabot ani. The height of the first floor is 4 meters. We can write that as that. And 1.25 H2 is equal to 4 meters daw. So to get the height of H2, we just divided this with 1.25. So our height of the second floor is 3.2 meters. And the height of the third floor is 1.33333H3, right? Is equal to 4 meters. Now, they are equality. They're all equal man this form. So we can manipulate the equation. And if we divide the whole equation with 1.333, we can get that the height of third floor column is equal to 3 meters. Wala siya. So, ato pa din kung hindi dapat to si H. No, I have forgotten to show you, but that's how we did get the height of the columns. So the height of the second floor column, mo na siya, 3.2, and then we have our stiffness, 5,324,055.687 Newton per meter, and then this is our equivalent stiffness of the columns in the second floor. And for the third floor, this is the stiffness of a single column at 6,461,431.731 Newton per meter. And then this equivalent stiffness no, sa itong third floor columns or columns supporting the third floor at 25,845,726.92 Newton per meter. So, since we have already calculated the stiffness of one column per floor, and then the equivalent stiffness of the columns per floor, then we are already done with the first part. So there are 4 parts. First, we're asked to find the stiffness. Second is the frequencies and period. The third one, we're asked to find the mode shift factors. And lastly, we're asked to draw or sketch the mode shift. We're done with the first part. And we are going to continue the second one, the determination of the natural frequencies, in the next video. So medyo kuti lang ni siya diri nga part no magsugod na kakuti when we are going to get the natural frequencies and the mode shapes of the building.